All right, so this is your Quiz 20 study guide. And problem number 1, you are simplifying all of these radicals, okay? So directions are the same for all of them. We got the third root of 162. Over the third root of 2. All right, so we're going to divide the 2 into the 162. We get the third root of 81. The third root of 81 has a perfect cube in it. All right, so this simplifies to the third root of 27 times the third root of 3. And the third root of 27 is a perfect cube. That's equal to 3. So in simplest form, we get 3 times the third root of 3. And that's your simplest form. Problem number 2, we've got the fourth root of 400 divided by the fourth root of 5. Now 5 goes into 400 evenly. So this is equal to the fourth root of 80. And then 80 has a perfect fourth in it. So when we break this 80 down, 80 is equal to the fourth root of 16 times the fourth root of 5. Fourth root of 16, or 16 is a perfect fourth. So this simplifies to 2. So we're left with 2 times the fourth root of 5. Problem number 3. Third root. 270 x to the 20th. Over the third root of 5x. All right, and again, the 5 goes into 270 evenly. So we're going to simplify all this. 5 goes into 270 54 times. And x goes into x to the 20th, x to the 19th times. Now, 54 has a perfect cube as a factor. So this third root of 54, it simplifies to the third root of 27 times the third root of 2. And this third root of x to the 19th, it simplifies to the third root of x to the 18th times the third root of x. It's x to the first, but we don't write the 1. So now this third root of 27, that's a perfect cube. That's equal to 2. The third root of x to the 18th, that's another perfect cube. That's equal to x to the 6th. So now we're going to put everything together that's not under the radical. So that's 2 times x to the 6th. And then we're going to put together everything that is under the radical. So that's the third root of 2 times x. Yeah, this third root of 27, that's not 2, is it?
It's 3, right?
Yeah, it's 3, sorry. So let's make that a 3 and a 3. All right, any questions up till now? Problem number 4. Square root of 90, x to the 18th, over the square root of 2x. And again, you can get the 2 goes into 90 evenly, and the x goes into x to the 18th evenly. So in the numerator, we get the square root of 45, x to the 17th. We can break those both apart. The square root of 45, that's equal to the square root of 9 times the square root of 5. X to the 17th, that's equal to the square root of x to the 16th times the square root of x to the first, but we don't write the 1. The square root of 9, that's equal to 3. And the square root of x to the 16th, that's equal to x to the 8. And then combine what's not under the radical, which is 3x to the 8th, and then combine what is under the radical. So that's 5x. All right, problem number 5. Third root of 9 over the third root of 11. Now, 9 is not divisible by 11, so we need to rationalize this denominator. So we're going to create a perfect cube in the denominator, and we're going to do that by multiplying both the numerator and the denominator by the third root of 11 squared, because this 11 is 11 to the first. So if we multiply the denominator by that, we need to do the same to the numerator. So now, in the numerator, we get the third root of 9 times 11 squared. 9 times 11 squared, which is 1,089. In the denominator, we get the third root of 11 to the third, which is the third root of 11 to the third is Nice. 11. So that is your simplest form. All right. 1089 doesn't have any perfect cube factors. No perfect cube goes into 1089 evenly. All right. And then number 6. Problem number 6, we got the square root of 6 x to the 8 y to the 9th. In the denominator, we got a 5 x squared y to the 4th. So the 5 doesn't go into the 6, but in the numerator, we got a 6. X squared goes into x to the 8th, x to the 6th times. Okay? Y to the 4th goes into y to the 9th, y to the 5th time. And it's all still over this square root of 5. So now we got to rationalize the denominator, and we've got to simplify the numerator. So we're going to rationalize first. We're going to multiply the top and the bottom by square root of 5. So in the numerator, we get the square root of 6 times 5 is 30. We get the square root of x to the 6th. And we have the square root of y to the 5th. And all of that is over the square root of 25 times the square root of 5. I'm sorry, the square root of 25 times the square root of 25. Jesus. Square root of 5 times square root of 5 is the square root of 25. And square root of 25 equals 5. So when you rationalize that denominator, you just get what was under the radical. So then this x to the 6th is a perfect square, and it simplifies to x to the 3rd. The square root of y to the 5th simplifies to the square root of y to the 4th times the square root of y. And the square root of y to the 4th is a perfect square, and it's equal to y squared. So now we need to clean up everything on the top. So be careful, this gets sloppy. We simplified this square root of y to the 5th, so get rid of it. Now up top in the numerator, what we have that's not under the radical, we've got an x to the 3rd, we've got a y squared, times, under the radical, we have a 30 times y, which is 30y. And then in the denominator, all we have left is the 5. And that is your simplest form. There's no perfect square factors under the radical, and there's no radical in the denominator. Does anybody have any questions on any of those 6 problems we did? All right, then you can use the rest of the period to work in the ALEKS app or to complete your electronic assignments for the week.